industry accepted use cases which everyone is following these days and implementing in their environment, right? These are the standard use cases. They are not pretty much complex. They are quite standard. Okay, so if you see this, yesterday we had discussion regarding the legacy WAN, right? Your hub and spoke architecture. So where uh, you have ordered the MPLS link, right? And your all the branches are connected through MPLS link, right? And on data center, we used to have the internet link. So your traffic flow was like this. I mean, if I will draw it here. So it used to be like this. Your private applications, they will be accessed via MPLS cloud, right? And if anyone would like to access the internet access, I mean internet applications, then also they used to break out through hub only, and we used to call it backhauling, right? So earlier this architecture was quite famous, backhauling of internet traffic. Local internet breakouts were not available. No site, no users, they cannot break out locally earlier as per the architecture, right? So we used to provide them central breakout from the hub location. Now, what is the demerit in this architecture? It's like you need to order huge bandwidth on hub location. So let's take an example. This is your hub data center location. Mostly we used to call data center as hub, right? So this is your hub location, and every other branch is connected through MPLS cloud. So your service provider will provide you the VRF, right? And through that VRF, you all are connected, whatever branches you have. And VRFs help to segregate the traffic from other customers. Okay. So this is your data center hub. This is branch one. This is branch two. This is branch three. Okay. So now I will use blue color to represent the private application traffic flow. So from this branch, your private application are getting accessed like this, right? And if I want to break out to the internet, let's take an example, you want to access any internet application, then we used to have the entire security stack on the data center only. Your DDoS blades, IPS, IDS, VPN concentrators, right? Firewalls. Entire security stack used to be on data center. Now your internet traffic flow will be like this. So let's take a different color for internet traffic flows. So it will go to the data center, right? It will be inspected by your security stack, and then it will break out to the internet. So earlier this architecture was very good. We call it legacy hub and spoke architecture. Earlier this was very good, reason being that we were having very less requirement of internet applications, right? Mostly applications were hosted inside the database, I mean inside the data center. Very less number of applications were available on internet. But nowadays if you see, your SaaS applications are increasing, right? Your SaaS applications are increasing. Your public clouds are available where you are hosting your services. So now there is a huge need for this branch breakout locally on the internet, rather breaking out centrally through the hub location. That backhauling is no longer supported now, right? Because first of all, you need to have a big pipe here on the data center. Let's take an example. If these sites they are having 50 Mbps of throughput, right? 50 Mbps each. Then on data center, you would need 150 Mbps to cater the requirement, your data flow, right? Then now on the internet link as well, here, if everyone is breaking out through internet, now here as well, you would need a good bandwidth, right? Because you are catering 3 sites. So this architecture is no longer supported now because use cases are different, and we need to break out locally. We need more internet related, I mean, these days we have more internet related applications, so we need more bandwidth on internet as compared to MPLS. This is one shift, right? Why SD-WAN has come into the market. This is one of the reasons. Okay. So this was a hub and spoke legacy architecture, which is no longer in place now. It is still there in banks, but still, banks have also started changing a shift from legacy to SD-WAN. Now, if we talk about the SD-WAN, right? So it also supports hub and spoke. Full mesh is also supported. So both options are available. Uh, Full mesh is also available and hub and spoke is also available. It depends on your use case. So it depends on your use case. Okay. So here, yesterday we have discussed one thing that in Fortinet we have one good feature, that is your ADVPN, Auto Dynamic VPN. So these are the shortcut tunnels, right? Because whenever you build any tunnel, it reserves some resources within your box, CPU, RAM, okay? Because IPsec is a complex function. Now, to save your resources for other complex operations, what this Fortinet has done, they came up with these shortcut tunnels. A shortcut tunnel is like whenever there will be a need for B2B communication, branch to branch communication, right? You need not to go via hub. You can directly communicate. So these tunnels will be live whenever there is a requirement to communicate B2B. So what I'm trying to explain here is in hub and spoke, the entire communication happens through hub. Spoke 1, spoke 2. In hub and spoke, entire communication happens through hub. So if this site would like to communicate to this site, my traffic flow will be like this, back and forth. Okay. If this site would like to break out to internet, then it will be like this. This was the legacy architecture. What ADVPN is offering you, that you need not to send your traffic towards the hub. We can communicate directly as well because we are connected through SD-WAN fabric, and internet is already any to any, right? So branch 1, branch 2, right? So if there is a need to communicate branch 1 and branch 2, they will form this auto dynamic VPN. We call it ADVPN, and your packet flow will happen there. Okay, there is no dependency on hub. So this feature will only work when you do the configuration. If you will not do the configuration, then ADVPN doesn't work properly. Another caveat is like these are the design caveats which we need to consider. Another caveat is like that you need to educate your customer that once entire deployment is done, then only you will be able to use this ADVPN properly. Okay. Sometimes customers they take it in a wrong direction. They think that see, when you do migrations, you cannot migrate all the locations in just one go. You do it one by one, right? One site, another site, then another site. So let's take an example. You have 200 sites and now you're rolling out your SD-WAN. So this is your hub location. So first we always do with hub or DC location. You can say hub or DC, and then we have DR, right? This is your SD-WAN fabric. And then first, let's take an example. We have migrated branch 1. You will still have other branches connected through MPLS only because we are doing the migration. And still your MPLS circuit will be live on DC location. So basically what we do, we create a parallel setup on DC, right? So sites which are connected through MPLS, they can still work, right? Because all of a sudden you cannot migrate all the sites. Okay, so you build the parallel setup like this, and once this branch 1 is able to do everything through SD-WAN fabric, then you can decommission your MPLS circuit or whatever you're using. Then you can decommission it and you can start using your new setup. So basically what happened initially, we just put a few test users, right? They do the testing, verify everything, then site goes for hypercare for 2-3 days. Once everything is smooth, everything is working fine, then we decommission these circuits. Then your next branch will be onboarded. So what happens? Few customers, they think that now one branch is having SD-WAN, and with this ADVPN feature, I can build dynamic tunnels like this. So this is not supported. So that's why we educate our customer that whatever sites have been migrated to SD-WAN architecture, only between those sites you can build the SD-WAN. I mean this ADVPN feature, right? So this is like design caveat which we put in our document so that customer is well educated. I mean customer is well notified before migration starts. Okay. Now why do we need branch to branch communication? So there are multiple applications which communicate, okay, within the branches, like your IP telephony, right? You have branch specific web servers. Okay, you have few departments, they need to communicate, right? You are still using older ways of communication. You are not using MS Teams or anything else, right? Still using older applications in which you have the dependency on the B2B communication. So sometimes people use B2B, branch to branch, and sometimes this term is also referred to business. Okay, so it depends on people to people, and it depends on the context, in which context we are using this particular keyword. Okay, now coming back to our discussion. So it's like hybrid transport. So like we discussed yesterday, that one will be your MPLS and another underlay will be of internet, right? So it's like on a critical locations, you're having MPLS and internet availability, and on less critical location, you are having only internet and Wi-Fi related, or you can say 4G LTE connection, like we discussed yesterday, right? So what will happen now? You are still able to build the tunnels. Okay. So yesterday someone was asking me that for call centers, how do we build the network architecture? So see, for any organization, if you take an example of any big organization, let me give you an example of EXL. I'm not sure whether you have heard of it or not, right? Now, EXL provides call center as a service to their end customers, right? So they have their IT team, IT network, as well as they have their and infrastructure available for the customers, right? Only for calling purpose. Now let's take an example. We have 3, 4 centers where, or you can call them BPO, right? So these are the branches where only agents will be sitting, right? And then you do have other branches where normal users are sitting, IT users, right? And then you have your data center. Now, earlier, all these branches were communicating through MPLS. But now, with the hybrid deployment, what we can do is we have this MPLS cloud, right? This data center, one underlay will be MPLS, right? And these are less critical. These are critical for me. These are less critical for me, right? So I'll use MPLS one underlay. Another another underlay on these branches, I will use internet, right? And here both the underlays were internet. Now one will be like internet lease line, and another one will be your 4G, LTE, whatever it is, broadband, whatever it is. You have the option, right? Now what is happening on these less critical sites? You are connected with the help of the IPsec tunnels, which we build as part of the SD-WAN fabric. Here, on the high critical sites, if you don't build IPsec tunnel by using the MPLS link, then also it is fine because you're still connected through a private network only, right? But if you build, it is good. And then another tunnel you can build by using this internet connection, right? Like this. So going down, I mean, MPLS link goes down, there are very less chances. Although it goes down, but still, if you buy it from any tier 1 ISP, they give you very high SLAs, service level agreements, right? 99.9%, 999, all five. So it depends on your, SLAs, what SLAs you have got from the service provider, and accordingly your links, they try to meet the SLAs, right? Until unless there is something very, it's like, some digging has happened and they broke the fiber or something like that, then only your link goes down for a longer time. Otherwise, MPLS, they're very stable. Okay. So for mission critical sites, for very highly critical sites, we always go with one MPLS cloud. And whenever voice traffic is there in picture, where the agents will be interacting with the user through PSTN network, then as per the DOT guidelines, MPLS should be there in the premise. Okay. For less critical sites where I know that my operations are not going to hamper much if my WAN connectivity will go off, then I can plan out my underlays accordingly. Okay, so we do it as part of the cost optimization. And same thing, we are able to see here. So this site was critical, this site was critical, this site was critical, although this is DC, right? So one link MPLS, another link internet. On on this particular site, this was less critical. So one link we have taken as internet, and another link we have taken it as LTE or 4G, whatever it is. Okay. So this hybrid deployment helps to meet your business requirements as well as do the cost optimization for you. Now, Now coming to site level high availability and device level high availability. Okay. So when we talk about high availability, okay. So high availability means that I want 100% uptime SLA, right? When I need 100% SLA, it means that my services should be up and running all the time, despite of any situation. Okay. So when we say site level high availability, so site level high availability means that you have DC, right, which is your hub location where your applications are hosted. And every other branch is connected to DC through this SD-WAN fabric, that is the IPsec tunnel. Now just imagine if something goes wrong with this DC itself, then what will happen? Let's take an example. You were having two underlays and both the underlays are down. In that case, this entire DC is gone, right? Unreachable. Then how your branches will do their normal business tasks, right? In that case, we have the concept of DR, disaster recovery, DR site, right? This is your hub 2. So hub 1, hub 2, right? And to connect these DC DR so that exact data can be copied on DR, because ideally DR just be on standby mode. Customers, they use P2P links to connect DC and DR, point to point links, Ethernet connectivity to do the data replication, so that whenever this DC goes down, your branches can connect to the DR and they can do their uh, normal BAU task without any outage. So this is your site level high availability. In case site is down, you have other site to cater your request. Now comes your you know hardware level high availability. Hardware level high availability means that if I have critical branch where I cannot afford a 1 millisecond downtime or 1 second downtime, something like that, right? So what I'll do, I'll put hardwares in high availability, active, standby, which means that if something goes wrong to this box can take over. Okay. So this is normal. Everyone is aware what is HA. Similarly, you have HA with your downstream switches, right? And then your other switches. So we ensure redundancies there to get 100% uptime SLA. Okay. So this is what it is. So here you can see at site level, I mean at particular branch level, we were having two boxes. If one box goes down, then we have other boxes to take over and operations can be resumed, right? On branch level, I mean on hub level, if any hub is down, right? If particular site is gone, then these folks, they can communicate to another hub, that is your DR site. Okay. And we have the P2P link connectivity. I mean, it depends on the customers. Either they take point to point, or they take IPs. I mean, they take another internet connection and build IPsec tunnel. So it depends on customers to customers, but mostly you will see that customers are buying P2P links only for data synchronization from DC to DR. Now in Fortinet SD-WAN, your high availability can be run as active standby and active active, right? One thing I would like to clear here, first of all, do not get confused by link active deployment. This is your FortiGate. This is your another FortiGate. You have built the high availability, right? Now let's take an example. This is my one underlay. This is my another underlay, right? And like this, we are extending it. We have the WAN switch here, WAN switch 1, WAN switch 2, right? Now you have two tunnels which are active by using one underlay and by using this another underlay. So these tunnels are active because you need to use both the underlays. But these hardware can be deployed in active passive or active standby, you can refer to it, right? Or hardware can also be deployed as active. Now, if it is being deployed as active, it means both will do the processing of the traffic. In active passive, only one hardware is doing the processing of the traffic. In active, both hardwares, they are processing your traffic. I mean, they are receiving traffic from the downstream switches and they are distributing these sessions within themselves. Okay. So these are the two different modes of high availability which is supported through Fortinet SD-WAN. So here in the picture as well, you can see ISP router 1, ISP router 2. This is your WAN 1, this is your WAN 2, right? And we have this primary, we have this secondary, right? Fortinet, these boxes, they also come with internal switch. Okay. After 60F, in 40F, you don't get this internal switch because that is the very starting model. In 40F, you don't get internal switch, but after 60F, you get internal switch. What is this internal switch? If you have noticed, when I was building this architecture, I was using these WAN switches because I need to extend the underlays. So I'll draw this architecture again so that you will be able to understand what I'm trying to say. When you buy two links from different ISPs, ISP1, ISP2, right? Now, these links, how will you terminate? Because you are not taking the CP from the ISP, right? We'll come to the marks. Through marks, it will be, let's take an example. It has been handed over to you. Now, how will you extend both the links to your SD-WAN routers? Router 1, router 2, right? If I will not consider these two WAN switches, then the options is like you can, let's take an example. This is MUX, ISP MUX, right? Now there are two options. If you want to get the redundancy of both the links on both the hardwares, option number one is like from MUX itself, you can ask your ISP that give me two handoffs, one on my router 1 and another one on my router 2. And same here, but this is very costly setup. uh, you know Normally they are not going to provide you this because some challenges are also there from pop to mux, right? If your ISP agrees to provide you this setup, then there is no need for the WAN switches, right? But if they are not providing you such setup, they will say that we can only give you one mux, I mean one link out of one mux, right? Because it's like, guys, these mugs are like this. It's not like that they will, give you hardware for each customer. No. In corporate sector, right, we have the IT parks. Okay. Now what they do, let's take an example. You have a big IT park where 1,000+ offices are there. Okay. So what they do, 1,000+ is a very big number. Let's take an example, 100 offices are there. So what ISP will do, ISP will put this mux inside the MMR room, meet me room, right? So whosoever has developed that particular area, right, that IT park, they create these MMR rooms. And these MMR rooms we also see inside the hyperscaler data centers, right? Whenever you order private connectivities, right? So you can take the handover on MMR. We will discuss more about all these terms later on, right? So in MMR, ISP will praise the mux. Now we have limited ports in the mux itself, right? If this particular premise is not your dedicated premise, you are inside a shared environment. Shared environment is like you have a very big IT park, and there you have your office on a particular floor. Now that cabling, right, that connectivity cabling is already done by the developer, whosoever has built that particular area, right? So that cabling is already done, and that's why these meet me rooms they get created, right? So that ISP, if you want to get connectivity from outside to inside, they will just put their box inside meet me room, and then internal cabling is already done by the developer, whosoever has built that particular project, so that you can reach the office. So I'll give you my example. Let's take an example. We have bought this office, right? So I was already having one cable, data cable in my office premise, right? Now, how we have got the internet access? So this cable was already provided to me by the developer, and this cable was coming from the meet me room, MMR room. Now there we have the ISP mux, right? So ISP lease line is coming from outside. It is getting terminated on the mux, and then this cable is getting connected to that mux, right? And this is how we are getting the internet access. Okay, so that's why sometimes it becomes very difficult that ISP will give you two outputs through a single mux, right? Sometimes there are technical barriers as well. I mean, the device which they are using, the hardware which they are using for mux, that doesn't support such setup, right? Because you need more next generation mux for this feature. So sometimes ISP will reject this option. Now, if ISP is rejecting this option, then how you can build your architecture for this setup, right? So another option is like this is your Fortigate 1, this is your Fortigate 2, right? And either you can terminate your ISP 1 link on Fortigate 1 and your ISP second link on Fortigate 2. Now, if you do this, right, and if you have deployed your boxes in active passive, okay, I mean this box is standby box, then how this one will use this link? So this is the smart thing from Fortinet. What they have done, they have provided you these internal switch concept. Internal switch. Now this internal switch means these boxes they come with switch modules. If you plug in the cables, right, this box is active, this box is passive, then this particular active box can use the both the underlays. How come? With the help of this internal switch. So first, it is using this underlay because it is already connected. Second, it will make use of this switch to access the internet through ISP2, like this. The only drawback here is like if any box goes down, then that underlay will also become unreachable. Then only one underlay is available. And since you are using them in active, so if my 50% of traffic was traveling through ISP1 and 50% of traffic was traveling through ISP2, right? If this ISP1 has become unreachable, then entire load will come on ISP2. So that's why this architecture fails in these conditions, right? We put such architectures in less critical infrastructure, I mean less critical branches. Now, when your operations are very critical, you cannot take any risk, right? So there, what we do, we put WAN switches. We connect them back to back, right? Now you must be thinking that my WAN switch can also fail. Then also this problem will come. So normally, we have noticed this thing, right? That your switches, they don't create much problem because they are not doing much complex operations as compared to the firewalls. Although FortiGate hardware failure rate is 2%, less than 2%. One link will go to the FortiGate 1, another link will go to FortiGate 2, and this is how we can extend our legs to both the FortiGates, right? And we can also connect them back to back. So here now what we have done, this is my WAN switch 1, WAN switch 2. Now, if you see the high availability, this was active, this was passive. My active tunnels are created from here, like this. Okay. And my standby tunnels by this FortiGate, they have been created like this. Right. Now try to understand the failover scenarios. If ISP goes down, then I have reachability through this ISP, right? If ISP2 goes down, no problem. I have reachability through ISP1. If active box, this box goes down, then this passive will become active. And then I have reachability like this. So this cross connection from switch helps you to have the reachability on both the ISPs. Now another failover scenario is like my WAN switch is down. So if your WAN switch will go down, then you will only have connectivity to ISP2, right? So this is also there. But in industry we have seen that switch failure rate is very less, although they fail, but still, it's very less. So still single point of failure. I mean, it's not a single point of failure, but still there are chances that if this WAN switch will fail, then only one ISP will be available for your traffic. So whenever we prepare the architecture for the companies, right, or for the enterprises, we consider all these failover scenarios and we, give them the explanation and all the detailed information about it. Okay. Now, another thing is like both devices, they are active. So one was like, you are connected through the hardware switch, right, in place. And another option is like internal switch, right? And you want to put your FortiGates in active mode, right? The boxes can be placed in active mode, which means that you can directly terminate one ISP router on this switch, another ISP router on this switch, the links, right? So this setup we do for active passive, right? You can see this cross connection, although they have forgot to mention this back to back connectivity. Okay, this setup is for cross connection, for active passive. When your FortiGates are in active, primary, secondary, active, right? So how do you do this setup? In this case, you can directly terminate your underlays on your boxes. So this is my FortiGate 1. This is my FortiGate 2, right? You can directly terminate your ISP1, ISP2 on each boxes. And then you can connect them back to back or you can make use of the hardware switch, right? It depends on you how you are connecting your boxes. This is also active. This is also active. They both are processing your traffic. Okay. So these are the architectures. Again, failure is there. If you are connecting ISP1, I mean terminating ISP1 on FortiGate 1, if this goes down, then this FortiGate will only have access to this particular ISP, right? And your entire downstream, these are the switches, right? They are also connected in cross connections like this for redundancy. So your entire traffic will start coming like this. Okay. So although we will do it in lab, so you will get more understanding about it. Now, if I will give you the broader picture that how things are actually there, in enterprise network, right? So yesterday someone was asking me about the private cloud, multi-cloud, branch, data center, right? Now in this topology, we have got everything. So here you can see we have the private cloud, we have multi-cloud, AWS, GCP, Azure, right? Oracle, and here you have your own private cloud infrastructure, and you can also get it from the hyperscalers. Then this is your on-prem data center, right? This is your branch office, another branch office, right? Now you have hybrid deployment. So you have purchased the internet connectivity. You have also purchased the MPLS connectivity. So on your data center, you have the MPLS leg. On your branch office, you have the MPLS leg. And then we have this, internet connectivity on my data center branches, on my private cloud, right? This red line is your internet connection. This green line is your MPLS. And these are the legends, right? So whenever we make any HLD, any architecture, so, we make these legends so that whosoever is referring to our diagram, they can understand what is depicting, right? This line, what is the meaning of this line? Black line. So this black line is nothing but internet overlay. Overlay means SD-WAN, SD-WAN tunnel, IPsec, MPLS overlay. So this green line is representing IPsec tunnel, which is built on MPLS underlay, right? And this red line is giving you the internet underlay connectivity. Okay. Because just imagine how you will design these things on a diagram, right? Underlay, overlay, how you will represent these thoughts. So with this, we can prepare the network diagram. Now here you can see that you know multi clouds, your public clouds, private clouds, they are connected through internet, right? But your branches is having hybrid deployment. One link is MPLS, another link is internet, right? And by using these links, we have built the IPsec tunnels, and we have ensured the reachability from these end devices to these end devices. Okay, this is your overall WAN architecture. Now, in your cloud, you have this option. You can spin up the virtual machines, right? In your security VPC, right? You can spin up your virtual machines and you can ensure the connectivity with the internet, right? You will take the internet gateway services from the hyperscaler, and then by using it, you can build the SD-WAN tunnel. And similarly, you can do it on your private cloud. Another option which is available with these hyperscaler was like private connectivity. A private connectivity is like if you have bought the MPLS cloud from any service provider, right? So this is the branch one. This is the branch two, right? And then your data center. Now, if you want to connect your cloud environment as well to this private infrastructure, let's take an example. I have this AWS, Now I want to connect to this AWS on my MPLS link. You can do that. We have the private connectivity options. So ISPs, they provide this. Okay, if you ask for it, you order the private connectivity from the ISP, and then ISP will arrange this connectivity. Then you need not to access your MPLS over internet. You can access it through MPLS as well. This is another secure way of accessing your public resources. Why this can be done? This can be done. The reason is like in India, if you talk about AWS, Azure, GCP, they are not having their own data centers. Okay, they have hosted their racks in the ISP data centers. So if you talk about Tata and other ISP, right, they have their data centers where these racks are also available, right? So many few companies are there, you know, at present. I mean, if I'll talk about the global business, so if AWS would like to, have a global reach, do you think it will be feasible for AWS to open up 200 plus data centers across the globe in a lesser time? Right? It cannot be done because data center is a very big facility. So what they do, they make arrangements with the local ISPs, right? Because local ISPs are already having their data centers, which we call it POP, like we were discussing it yesterday, right? So there you can have your racks, rack 1, rack 2. Let's take an example. This rack 1 is of AWS, this rack 2 is of Azure, right? Okay, and this ISP is, let's take an example, Airtel. Now, if you have bought the MPLS from Airtel, now Airtel is also offering this private connectivity, which means that if you have the cloud subscription, we can provide you this private connectivity as per your region. Let's take an example, Indian customer, they need this private connectivity. Okay. So this, private connectivity will be like this. This Airtel, already these racks are hosted within the Airtel premise. So they will connect the cable to this rack and then they will extend it to this MPLS. So in AWS, we call it private connectivity. In Azure, we call it express route, right? So all these options are available, right? And then I'll discuss more on multi-cloud connectivity and how you should be connecting it these days and how we were doing it previously. All these things we will discuss. So I'm just pausing it here. If you have any doubts, anything, you can let me know. Here's our AWS, Microsoft, and Google. Although these options are now available with all the cloud providers, right? Most of them, they offer this service. If I talk about this AWS, right? So here you can see this is the product name, Direct Connect, right? Create a dedicated network connection to AWS. So basically, what ISPs have done, you know, they have already done this backbone connectivity. So let's take an example. This is the ISP network, right? So I'm just visualizing it with the help of the box so that it helps to, understand the concept what we are trying to say here. And this is AWS. Although this rack could be within this ISP infrastructure, right? What this ISP has done, they have already done this connectivity. Let's take an example. They have taken this 100 gig pipe between AWS and this ISP, Tata, Airtel, whatever it is, right? Now, what they do whenever any customer comes, if they are using, any end customer is using MPLS services from this ISP, and now they need this private connectivity. So we can add this particular spoke location, right? And we can buy this direct connectivity And out of 100 gig, you can take minimum bandwidth like 50 Mbps. So you can take the 50 Mbps port, right? Similarly, another customer can buy 100 Mbps. So basically, it's like a dark fiber connectivity between this ISP and the hyperscaler. And then, this ISP is further sending these chunks of the bandwidth to the end customer, right? So this is how it is. Now, when you go here, you see find a direct connectivity delivery partner. So if you click on it, they will give you the details. So, okay, right now I'm not logged in, right? They are asking you to connect to the AWS partner sales. When you connect with them, they will give you the ISP names through which you can order this direct connect. Okay, Tata is one of them, and Airtel is also providing in India, right? If you talk about overseas, BT, AT&T, Orange, all these they have this feature available. If you go to Azure, now this is Express Route. Okay, so this is like same connectivity. So partner edge, partner will be your ISP only, right? Your ISP will provide you this direct connectivity to the Microsoft Edge, right? So basically, you need to have the service key, or you can say in case of AWS, you need to have the account ID. And on that basis, this is done. Okay. And then this is the customer network, and you will be able to access your clouds infrastructure securely and privately. And you will have, obviously, you will have better routing, right? You're not dependent on internet routing. Now comes your Google Cloud. So in Google, you have this direct peering overview, right? Now, in Google, few services they work on, Google private cloud or internal infrastructure. So, in Google, there are certain restrictions when you go for the peering. So normally you will see Azure and AWS. This is widely used, these services. Mostly every other enterprise, they buy this subscription. But when it comes to, this Google, there is one application, I'm forgetting the name. I think it is Speakeasy. So that application has been hosted inside the Google, although it is a public cloud, but still inside that public cloud, there is one internal network of Google. In that network, that application has been hosted. Now, to take that particular access to that particular application, there is Google public peering available, and that it needs 1 gig of port, I believe. You need to buy 1 gig port from Google. Cost is also very expensive, right? And then you can make that application work for you. So, all these hyperscalers, they are providing you these support. Okay. Now coming to the multi-cloud connect. This is from the, from one hyperscaler perspective. But now just imagine that I have multiple clouds. Enterprise A is having multiple cloud presence, right? AWS, Azure, GCP, Oracle, right? Now, what options you have? Okay. So when we are discussing about the SD-WAN, so what you can do is already your network is up and running. This is your data center, SD-WAN fabric. You have your branches. Now, how can you onboard your cloud? What options you have, right? Option number one, local internet breakout. Now, local internet breakout means that you're breaking out locally from the branches towards the internet, and you are accessing these clouds over internet, which is not a secure way of doing it. This is option one, but it is not secure. Another option is like uh, option two, that you spin virtual machines within these cloud environments, and you make them part of the SD-WAN fabric. That is another option, that in AWS you are spinning up Fortigate virtual machine. In Azure you are spinning up Fortigate virtual machine. Same with Google, right? Same with Oracle. You are doing it and you are building your fabric. Now here the thing is, when you do this architecture, it is doable, feasible, it can be done. There are certain cost elements which gets added on, right? First is like running cost of this VM. You need to bear that. Another is like you need to bring your own licenses, right? And then third one is like your internet charges. Incoming data is free, but outgoing data is paid in hyperscaler environments, right? So whatever data will exit through this, you need to pay for that. So these are the cost elements which are there when you build your tunnels like this, when you extend your SD-WAN fabric like this, right? Now someone was highlighting regarding Equinix, right? Now Equinix is a big player, so they provide data center services. So now what happens? Equinix says that all these clouds, mostly they are hosted within my data centers, right? So what Equinix is offering you, Equinix is saying that this is my premise. You take one network edge device from me. Basically, it is a compute which you buy from Equinix. Buy that compute, spin your virtual machine here. It could be your SD-WAN device, Cisco router, firewall, whatever it is, right? In our case, definitely it will be the SD-WAN device. And build your entire fabric. I mean, just connect your fabric with this SD-WAN device. So your data center is already connected. Your branch is already connected, right? And now you have connected your Equinix node as well. And these hyperscalers are already connected with me. Take this connectivity from me, and we call it multi-cloud connect. So you have AWS, you have GCP, you have Azure, you have Oracle. Now, by doing this, what we have done, we have optimized the cost. Now you need not to spin up individual VMs on these hyperscalers. You need not to build the respective tunnels. You need not to pay for the running cost. You need not to pay for the outbound data, right? What you need to do is you just need to buy this compute from the Equinix. You spin up your device there and you take this direct connectivity from the Equinix directly. And this is how you optimize the cost, right? So my senior, Mr. Murli, right? He was with me in Tatacom. So he is taking care of this product, right? And multiple, I mean, there are so many places where he has given very beautiful narrative regarding this, right? And how it helps enterprises to, save cost if you go with the multi-cloud connect. Okay. So this is very good topic, and now it has started gaining market. So now you can understand, how things are gaining market, new products everywhere, right? So earlier, enterprises were only restricting themselves to a particular cloud. But now, when they have seen outages, as per the Gartner, it is recommended that you have multi-cloud presence. Okay. And there are few applications which works well with Azure, which works well with AWS, GCP. So now customers, this is the, it's like a dependency on the customer to have multi-cloud presence. And when you are having multi-cloud presence, you need a solution so that you don't end up paying huge money to the hyperscalers, right? So when you need to optimize the architecture, now this is a new solution, multi-cloud connect, MCC. Okay. Now coming to that part, how hyperscalers are giving you 100% uptime SLA. Okay. So if I talk about AWS,
Nitin, can I ask one question or can we take it query? Because we are in flow, I wanted to ask one question here.
so Sachin, it breaks my flow if you will ask it
No, I
in
just
a
want
doubt session.
no, just wanted to whatever solution you saw. I mean, you show that about that. So again, I mean, this solution again, traffic is hairpinning, right? I mean, everything is traffic is hairpinning to the Equinix data center,
No,
right?
no, it's not hair pairing.
Okay.
Okay. So it's not hair pinning. The reason being that you just don't have one pop of Equinix, right? So it's not like that, you're sending it to the Equinix one location. Let's take an example, Singapore, and then these racks are present somewhere else. These racks are also within the same premise. And then you buy, if you have multi-region presence, then you buy these network edge computes as per your presence in the cloud environment, right? You select your region where I need my compute to be, right? So wherever you have bought your computes, accordingly, you will select this compute from Equinix so that they have local presence only. Otherwise, what will happen? You're sending your entire, let's take an example, this customer is from India, and if I will be sending entire traffic to Singapore, and then from Singapore it is breaking out to America or somewhere else, then it becomes hair pinning, and it is like not worth investing the solution, right?
Okay.
So
Okay.
here the thing is like everything is within the same premise. If this is the Equinix Singapore data center, then these hyperscalers are also available there in the same premise.
Okay.
Okay.
Okay. Okay. Okay. So they're providing the network as a service, right?
See,
Like
multi-cloud connect is the product name.
okay.
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 Yeah. So now I was talking about AWS Direct Connect, right? Now AWS Direct Connect is like oh sorry, the internet connectivity. How these hyperscalers, they are giving you 100% uptime SLA, right? They say that we never go down. So guys, just try to understand this thing. That what is cloud? Cloud is nothing. It is just hardware available on rent. That's it. This is what cloud is. So what people have done, they brought up the hardware together, huge compute, and now they are just selling it to you as per your requirement, and they are charging you as per your utilization, right? You need not to worry about the hardware, you need not to worry about the brand, underlay connectivities and all that stuff, right? They have already done the procurement. Now they have their operating system, that is the front end, through which you interact with this hardware. Okay. Through this, you interact with this hardware, and you are able to provision your virtual machines. Now, these hyperscalers, they take multiple connectivities. internet connectivities. Let's take an example. They have taken one link from Tata, another link from Airtel, another link from SIFI, right? The way they are providing you this hardware as a, on a rent, right? Similarly, they have clubbed these internet cables as well. So it cannot be possible that Tata is also down, Airtel is also down, SIFI is also down, and you don't have internet connectivity. Okay. How this is possible? Whenever you become the service provider, you participate in direct internet routing. Okay. So what happens? You have your own ASN number, BGP, and you have your own public IP subnet, right? Let's take an example. This is AWS edge router. Now, one leg is coming from Tata, one leg is coming from Airtel, and one leg is coming from SIFI, right? And AWS is advertising the subnet and the ASN inside the internet. It is participating in internet routing. You can do that. So this AWS router will also receive, at least 30% of internet routes or 40%. You can obviously ask ISPs to filter out the routes, and bigger subnets you can ask for, rather getting the small subnets, and you can, optimize your routing table. But this router will receive at least 50,000 routes from these ISP routers. And this subnet, whatever ASN AWS has, it is live over internet. And that is what direct internet access is. Do you think that when you buy a broadband connection, you're getting direct internet access? No. First, your when you buy any broadband connection, right? First, your packet goes and hit the local ISP setup, whatever setup router switch he has. From there, it goes to the big ISP in that data center. And now this chain, how much big is this chain? Nobody is aware, right? It depends. And then from there, it breaks out to the internet. Now, sometimes I have seen that people in Delhi, they are breaking out from Bangalore or Chennai or Mumbai, right? They are not breaking out to internet directly. Okay. So that is not direct internet access. Direct internet access means that you are directly participating in internet routing, and anyone can reach out to you from anywhere because your routes are advertised from your location, right? So if Tata goes down, so whosoever was asking that question, that how they maintain 100% uptime, so it's like if Tata goes down, still I have reachability through Airtel, I have reachability through SIFI, and whatever public IP you get from AWS on your devices, right? That is available over internet. You can reach out to any path. You can reach out through Airtel, you can reach out through SIFI, you can reach out to Tata. If any link is down, then you will reach, you can come like this. So let's take an example, another example I'll give. And this is the common use case we used to get, you know, uh, when I was in Tata, right? Because Tata is a service provider, okay? So this was the common use case we used to get. Let's take an example. I want to host my services. My website is up and running. NGCLOUDX is up and running, right? This is my application server. Okay. Now it is connected to my switch. Then we have firewall. Okay. And then you have your ISP circuit and you have got the internet connectivity. Now just imagine only one ISP connection I have taken. So now just imagine if this link goes down, my website is unreachable because you guys are accessing it over internet, and if something goes down, then I cannot access it. It is down, right? So in that case, I need dual ISP connection, dual ISP setup. So ISP1, ISP2. Now, if you are buying two ISP lease lines, right? So by default, they give you /29 public IP subnet free when you buy any public, any lease line. Now these links, they are getting terminated on your device. That is your you know, customer provided equipment. So on your CPE, these two links are getting terminated. And you have done the NAT on your application server by using this particular public IP pool. So let's take an example here. You have defined 115.112.79.180. This public IP, you have done the DNAT here, destination NAT, for this server. This server was having the private IP 192.168.1.2, right? You have done this DNAT. Now, this public IP was coming from this ISP1. This is not your public IP. Okay. Now, if this link goes down, your website will become unreachable. Although you will say that I have taken this public IP, I am having dual ISP connection, then why this IP is not reachable? Because this IP is only reachable through this through this network only, and that network is down. So that's why whosoever is the service provider, they buy their own public IPs. They buy their own public ASN numbers, and then they directly participate in internet routing. They advertise their ASN, they advertise their IPs in the internet route so that this ISP route is also aware that this IP is live and it is live from here and I have the reachability. That's how your BGP works. Okay. So this is how your hyperscalers are also working, and they ensure 100% uptime. Okay. Now coming to this another option which we have, that is your broadband enterprise branch. Now here, as you can see, we have internet connectivities only. We don't have MPLS or something like that, right? Now, you can have dual broadband connectivities, or you can just go with this option like one internet lease line and another one is like broadband, right? So this link could be your ILL, this link could be your broadband to optimize the cost. And then you can build your SD-WAN fabric. And with internet, the only benefit is like, it is any to any, because in MPLS, mostly MPLS, you will see hub and spoke. Okay. That is not any to any. Either you need to ask your provider to make it full mesh. Then only each site will be able to reach another site, and then you can go with that full mesh topology, right? But in internet, it's already any to any. Any site can ping another site because IPs are routable over internet. Okay. So you can build your SD-WAN tunnel. And another good part here is like you can provide local breakouts to the internet for all these branches. Now you are decentralizing your internet access. This is what we have started our discussion from, that when you backhaul your internet traffic, you are putting more load on data center, more bandwidth is needed, and latency is there. And earlier, internet bound applications were very less, but these days, internet bound applications are huge, right? Everything is going over internet, and SaaS based products are coming. You would need direct internet access, right? Now, if you need direct internet access, your user should break out to internet locally. You need a mechanism so that you can do the inspection and you can, split your private and internet traffic in a smarter way. And that is what it is, so SD-WAN. Okay. Now, if I will draw it with the help of the whiteboard, so it is going to look like this. So let's take an example. This is internet through ISP1, and this is the internet cloud through ISP2, right? Here you have branch 1, and here you have branch 2. Okay. And then you have your data center where your on-premise applications are available. Now you have this connectivity. So you have connectivities like this, right? And now you will build your SD-WAN fabric. So you will build the tunnel like this. This is your one tunnel. This is your another tunnel, right? And similarly for this branch, again, the tunnel is like this, right? And from here, like this. So this is your connectivity from WAN perspective, right? And then you have your internet. You have your SaaS applications. Okay. Now, your private applications will flow within the tunnels because they are only inside the data center. But your internet traffic, it can break out locally. Your SaaS based traffic, it can break out locally by using the underlay. It will not take the overlays. Same with this branch. Internet traffic will break out locally. SaaS traffic will break out locally by using the underlays. It will use these these links only. Okay, just for representation, I'm taking these arrows. So it will go like this only, but it will not take this overlay. It will take the underlay. So when we create rules inside the SD-WAN devices, we define that this particular traffic will be using overlay. This particular traffic will be using underlay. Okay, so this is how we split the architecture, that my private applications will be reachable like this, my public applications will be reachable like this, my SaaS based will be like this. Now comes your remote users, right? So with the help of the SSL VPN clients, they can also connect. So I'll take that up as well in our future discussions. Okay, so this is how your overall architecture looks like. So coming back to here, and you're breaking out securely because we assume that when you're doing local breakout, you have already bought the licenses, right? Next generation firewall licenses. Because if you're breaking out locally unsecure, then there are chances that you will download the malware, and then that malware will do the lateral movement within your network. Now, it is like you have cloud presence, okay, and in Azure, your mostly workloads are hosted in Azure, right? And you have the Azure virtual WAN, okay, and similarly, you do have a private cloud also within the Azure, right? So here you can see that this particular link, right? Your this is your internet overlay, the overlay which you are going to build by using the internet, right? And these are your SD-WAN devices. Okay. Now, I'm not sure whether you have worked with Azure Virtual WAN before or not, right? So think of it like a edge device only, just for your understanding, that through which you can have the connectivity of your VNets. Okay. Now you can build the fabric with your Azure Virtual WAN. You can build the fabric by other branches as well by using the internet. Okay. So this is also another way you can, you know, have your connectivity, and with the help of the direct internet access, you can build your fabric like this, right? We do have one concept, cloud on RAM, right? So all these things comes inside cloud on RAM strategies only. How you are going to bring your cloud as part of your network. So multiple options are available publicly, right? Over internet, like everyone is accessing. So these days, what you do, you spin up one virtual machine in the cloud environment, you get the keys, right? And you control your access through security rules that only this IP can access it, or these set of IP, these set of users. You create the, uh, you know, identity access management rules, right? And accordingly, you access your resources over internet, and you think that this is secure. No, that is not secure. Still, there are chances machines can be compromised. Now, what other options you have? So we have already seen private connectivity options. Each hyperscaler is giving you that option that, you can connect with me privately and securely. Although I'm a public cloud provider, but still there is a way you can connect with me privately so that we can minimize the risk of the attacks, right? Then other option is like build virtual machines, I mean spin up virtual machines in those hyperscaler environments, and through that you can have the IPsec tunnels and you can extend your fabric. Okay, and that is another option. So multiple connectivity things are available in the market these days. It all depends upon the architect who's building the architecture of that particular enterprise. And see, it's like if you want to come into this domain, especially in pre-sales, then the expectation of the management from you will be like that you should know everything. Now you can understand, right, how complex it is. You cannot become an architect if you don't know everything, because so many things, so many services you need to bring it together. You need to do the service chaining of different solutions, right? Then only you will become the solution architect, right? So you should know how these things will work. And then you need to represent it, then you need to present it to the customer end, as well as once the contract has been signed, then you need to uh, you know give this understanding to your internal teams, your delivery teams, your support teams, because they are going to deliver it and support it. So whatever you are selling, you should know what you are selling. If you don't have any idea what you are selling and you have just sold it to the customer, then you can just imagine during delivery it will have hiccups, right? Roadblocks. And if the solution which has been agreed by the customer, which has been agreed by you, because there is a contract which gets signed off, if those things are not being met, obviously the deal will get cancelled and you will have penalty clauses and all that stuff. Okay. So another thing with MPLS, it's like one caveat is there with MPLS deployment, that is your hybrid deployment. So you have the MPLS and you have internet, right? This is your branch one, and this is your data center. Now you're connected like this, and we are assuming that both underlay overlay. You're able to understand, right? Or let me just draw it. Underlay is yellow line, overlay is this. Okay. Now just imagine you only have one internet connectivity, and you're accessing your SaaS applications and other internet bound applications through this link only. You're breaking out locally because through MPLS you don't have connectivity to internet, right? Now, if this link goes down, your branch will have outage for SaaS based applications, internet based applications. So, what will you do? So, in that case, we can route the internet traffic via MPLS, and from DC it can break out to internet. This could be your failover architecture. Okay, because only MPLS link is up. Because in MPLS, you cannot break out to internet until unless your service provider has given you that functionality. If that functionality is available, that service provider is saying that MPLS cloud, it is having internet access, you just need to pay extra. And through this MPLS cloud as well, you can break out to internet. Then you can break it out. But if you don't have internet breakout through MPLS, then you need to send your traffic to the data center, and from data center you need to break it out to internet. So it will be backhauling again, but this is for failover condition in case your internet link goes down on any branch. Okay. Now cloud on ramp. So we have already discussed this thing, right? I have already shown you that this Equinix, they are offering this network edge, right? And you can buy the compute. On that compute, you can spin up your virtual device. It could be SD-WAN, it could be Cisco router, anything, firewall. Okay. And you can build the tunnel from your SD-WAN device to that device. And already all these hyperscalers, they are available within the Equinix data center. All the racks are available, right? And then you can take this private connectivity and you will get the better performance of your cloud applications and more secure access, right? So this is another way you can, onboard your cloud environment to the SD-WAN fabric, right? So we have already seen it. Now let's move on. Another thing is like, you have Azure, you have AWS, you have Google, right? Multi-cloud presence you have. On branches, we are sorted that we have this Fortigate appliance on my branch. On my on-premise data center as well, I have Fortigate appliance, and I can build my tunnel, right? That I understand. Okay. Now, another option is like when you have multi-cloud presence. Okay, so now your multi-cloud presence is like in Azure, how can you communicate? You can communicate through virtual WAN. You can communicate through express route with other networks. In Google, you have this interconnect, right? And in AWS, you have this direct connect and transit gateways. Okay. So what you can do is you can spin up your FortiGate VMs in these cloud environments, and then you can establish your fabric. So I already told you that it will be costly. Costly why? Because you need to bear the running cost, you need to bear the data cost, right? And you need to bring the licenses. So overall, it will be a costly solution, and performance will be degraded as compared to this solution. This solution is now gaining market because people are able to, I mean, the not the people, the CTOs, CEOs, right? They are able to understand the cost benefits and the better way of accessing the applications. Okay. Now if I will discuss my integration with SASE platforms, how I can have fully compliant SASE architecture. If I'm going with Fortinet SD-WAN and Zscaler, right? So what I will be doing in my office, I will have FortiGate appliance, right? I'll build my IPsec tunnels with the Zscaler Zen nodes, and through that Zen, I will break out to internet. So your architecture will look like this. That on my branch, I have FortiGate. FortiGate appliance is there, right? On my data center, I have FortiGate appliance, right? You can build your SD-WAN fabric by using your underlays. That is nothing but IPsec tunnels, right? So your private application traffic is flowing very well. Now let's take an example. You have not bought security licenses from Fortigate when you were buying these boxes. Instead of this, you have bought Zscaler subscription. Now, what are the options? You can integrate Zscaler with Fortinet. So first option is like with Zscaler Cloud, you can build the dedicated tunnels. So from here, you have built dedicated IPsec tunnel with Zscaler Cloud. That is nothing but your internet access service, and you have Zen nodes, right? Now your internet traffic will flow like this. It will come from branch location from your LAN, hit the edge device, then it will take this dedicated tunnel, hit the Zen node, and it will break out to internet. So Zscaler will provide you the inspection. Then similarly, it will go out for SaaS based applications. And similarly, from data center, if any LAN user is there, would like to access the internet, it will be like this. This is one integration where we are going to build the dedicated tunnels from your device to the Zscaler Zen. Another way is like now these tunnels could be IPsec or it could be GRE. It's your call which tunnel you need to build. Another way is like you know you can make use of Zscaler client connector. ZCC, right? Now that ZCC, in that case, you don't have these tunnels. Okay. So in that case, what will happen? Your traffic flow will be like this. So this is your branch, right? FortiGate is sitting here on your edge. Then you have your LAN infra. And let's take an example. This ZCC is installed within the user machines. Okay. You have your SD-WAN fabric built with the data center. This is your data center where your applications are hosted, right? These are your application servers. Now, what you will do in GCC app profile, you will bypass internal subnets, private subnets, so that whenever any user is trying to access the internal website or internal application that is hosted within the data center, it will go directly like this, right? You will bypass these internal subnets within the GCC app profile. But if you want to send your internet traffic and SaaS based traffic through Zscaler, then that should be included inside the app profile, right? You will add this default route that it should be included. Now, what will happen whenever user will try to access Facebook, YouTube, the Zscaler client connector will build the tunnel with the Zen, nearest Zen. Now, this tunnel could be 1.0, this could be 2.0, it depends as per your configuration. And then it will break out to internet. Now, what drawbacks we have with this particular architecture? The only drawback is like your edge device, this Fortigate, will lose the visibility of these applications because ECC will encapsulate the will encapsulate the end application traffic within these tunnels. And on Fortigate, you can only see Zscaler app. You won't be able to see the end user application. And if you are not able to see the end user application, and if you have taken the dual ISP connection, then how you will be able to do the traffic steering? That you cannot do. So this architecture is having the limitation, right? And then comes your single sign on and all that stuff. So all these things we are going to discuss in our course, right? And I'll try to keep it lab oriented so that you can, try to do all these things and you can understand all these things in a better way, right? Now I'm open for doubts. If you have any doubt, anything, you can just let me know.